this. Prove that 1 plus cot square theta by 1 plus cosec theta is equal to cosec theta. Now starting with the left hand side, here no chance of using the algebraic identities because you do not have square over two simultaneous terms. So here we have cot square theta. Looking at cot square theta, we know that we can use one of the identity. Look, we know that 1 plus cot square theta is equal to cosec square theta. Now if you look at the denominator, it also has cosec. If you look at the right hand side, it is also about cosec. So we can happily change this. Okay, we can substitute this cot square in terms of cosec. Now transferring one to the other side, we can write cot square theta is equal to cosec square theta minus 1. Okay, now looking at cot square theta, this can easily be replaced with cosec square theta minus 1 by 1 plus cosec theta. Okay, now this becomes very interesting. Here you have cosec square theta and here you have minus 1. So can this be written as, look at this step, can this be written as cosec square theta minus 1 square? So again, this is nothing but a square minus b square form. Okay, so or x square minus y square. We know x square minus y square is x plus y into x minus y. So similarly over here, okay, over here I can write 1 plus, since this can be written as x square minus y square, and we know x square minus y square is x plus y into x minus y. So here we can write cosec square theta minus 1 square theta as cosec theta plus 1 into cosec theta minus 1 divided by 1 plus cosec theta. Now this is very important one. Look, 1 plus cosec theta and cosec theta plus 1 both remain same. So here also you have cosec theta plus 1, here also you have cosec theta plus 1. We can cancel each other. So what we are left with? We have 1 plus cosec theta minus 1. 1 minus 1 is 0. So we have cosec theta. Look at the right hand side. So looking at left hand side and right hand side, we can say LHS is equal to RHS, and hence it is verified.